of the session. In this session, we will concentrate on theorems of Laplace transform. So, some of the theorems related to Laplace. So, the first one is initial value theorem. Now, this initial value theorem is if f of t and f dash of t are Laplace transformable, then f of t in the neighborhood of t equal to 0, that means limit as t tends to 0 f of t, limit as t tends to 0 f of t is equal to s f of s equal to s f of s in the neighborhood of s equal to infinity. That means limit as s tends to infinity. So, according to the initial value theorem, limit as t tends to 0 f of t equal to limit as s tends to infinity s f of s. So, proof. So, how to prove this? Now, as we mentioned in the beginning, f of t and f dash of t are Laplace transformable. So, Laplace transform of f dash of t, Laplace transform of the derivative function f dash of t, and from the derivatives we know that s f of s minus f of 0. Laplace transform of f dash of t is equal to s f of s minus f of 0. Now, based on the first principle method or based on the formula, this Laplace transform of f dash of t is equal to 0 to infinity f dash of t e to the power minus st dt equal to s f of s. This is based on the derivation minus f of 0. Now, apply limit as t s tends to infinity. By applying limit as s tends to 0, s tends to infinity, on both sides, what will happen? Limit as s tends to infinity, integration 0 to infinity, f dash of t e to the power minus st dt equal to limit as s tends to infinity, s f of s minus f of 0. Now, when I substitute limit as s tends to infinity, this e to the power minus infinity becomes 0. So, left hand side is 0. On the right hand side, limit as s tends to, based on the property of infinite limits, limit as s tends to infinity s f of s minus f of 0. Because this f of 0 is not a function of s, so value of f of 0 when s tends to infinity remains the same as f of 0. So, f of 0 equal to limit as s tends to infinity s f of s. F of 0 means what? Limit as t tends to 0 f of 0 equal to limit as s tends to infinity s f of s. So, this is all about initial value theorem. So, for the given any f of t, we can find out f of 0 by using Laplace transform such a way that limit as s tends to infinity s f of s gives f of 0. Sorry, this is f of t. Final value theorem. Now, according to the final value theorem, if f of t and f dash of t are Laplace transformable, if f of t and f dash of t are Laplace transformable, then f of infinity, that is limit as t tends to infinity f of t, equal to limit as s tends to 0 s f of s. So according to the final value theorem, if f of t and f dash of t are Laplace transformable, then value of f of t in the neighborhood of t is equal to infinity is equal to value of s f of s in the neighborhood of s equal to 0. So proof. In the similar fashion, Laplace transform of f dash of t equal to, based on the concept formula 0 to infinity f dash of t e to the power minus st dt, and according to the formula s f of s minus f of 0. Now applying limits as s tends to 0 on both sides. So when I apply limits on both sides, what will happen? Limit as s tends to 0, 0 to infinity f dash of t e to the power minus st dt, equal to limit as s tends to 0 s f of s minus f of 0. Now when limit as s tends to 0, this e to the power st becomes 1. So it becomes 0 to infinity f dash of t dt, equal to, here in the right hand side, limit as s tends to 0 s f of s minus f of 0. Now what is the integration of f dash of t? It is equal to f of t, and in the interval 0 to infinity. That means f of infinity minus f of 0 equal to limit as s tends to 0 s f of s minus f of 0. So this f of 0 gets cancelled. So f of infinity equal to limit as s tends to 0 s f of s. So this is the final value theorem related to Laplace transform. So using this initial value and final value theorems, we can find f of 0 and f of infinity for the given f of t. Next, convolution theorem. Convolution theorem. Now, according to the convolution theorem, if f of t, f1 of t and f2 of t, two time domain function, f1 of t and f2 of t are Laplace transformable, then Laplace transform of f1 of t convolution f2 of t equal to f1 of s f2 of s. So according to the convolution theorem, if f1 of t and f2 of t are Laplace transformable, then Laplace transform of f1 convolution f2, this indicates convolution. In maths you might have studied convolution. So Laplace transform of convoluted signal is equal to f1 of s f2 of s. Now f1 of t convolution f2 of t, what is this? f1 of t convolution f2 of t means 0 to t f1 of t f2 of t minus tau, sorry, f1 of tau f2 of t minus tau d tau. So according to the convolution property in mathematics, f1 of t convolution f2 of t is equal to this. So Laplace transform of f1 of t convolution f2 of t equal to 0 to infinity. This is based on Laplace transform. 0 to t f1 of t f2 of t minus tau, sorry, f1 of tau d tau e to the power minus st dt. So this is based on a Laplace transform formula, integration from 0 to infinity. Then this is f1 convolution f2 into e to the power minus st dt. Now in this f2 of t minus tau, which is in the interval 0 to t, can be written as 0 to infinity f2 of t minus tau u of t minus tau. Integration f2 of t minus tau can be written in the limit integration 0 to t can be written as 0 to infinity f2 of t minus tau u of t minus tau d tau. Because this u of t minus tau is 1 for t greater than 0 and 0 for t less than 0. So based on that, if I consider 0 to infinity limit also, this value is 1 only for a specified interval. So for all other it is 0, so entire term becomes 0. So only in the interval 0 to t it acts. So if I substitute this in this equation, so this Laplace transform of convolution, this is the 2, this is the 1, substituting 2 in 1, so this 0 to infinity, then 0 to t I will write as 0 to infinity f1 of tau f2 of t minus tau u of t minus tau d tau e to the power minus st dt. So here double integration, one is with respect to tau and one is with respect to t. So here t is common to this. So as a double integration with respect to two different variables, we can interchange this. So by interchanging this, what will happen? 0 to infinity f2 d tau I will take outside, so f1 of tau, then it is only with respect to tau, so it is not a part of t integration. So 0 to infinity f2 of t minus tau u of t minus tau e to the power minus st dt. Now then d tau. So integrating with respect to t separately and then integrating with tau. Now 0 to infinity f of t minus tau u of t minus tau e to the power minus st, what it is? So based on a shifting theorem, it becomes 0 to infinity f1 of tau. What happens to this? E to the power minus s tau into f2 of s. d tau. Correct? Based on a shifting property f of t minus tau u of t minus tau e to the power minus st dt is equal to e to the power minus s tau f2 of s. So now this is integration is with respect to tau and this is the constant. So it is equal to f2 of s integration 0 to infinity f1 of tau e to the power minus s tau d tau. So integration 0 to infinity f1 of tau e to the power minus s tau d tau. Variable is instead of the t, it is the tau, but this is same as f1 of s. So it is equal to f2 of s into f1 of s. So convolution is equal to f1 of s, f2 of s. So Laplace transform of two convoluted signal f1 of t convolution f2 of t is equal to f1 of s, f2 of s. This is also one of the very important theorem in Laplace transform. In this session we have studied what is the initial value theorem, what is the final value theorem, and also convolution theorem. So these three theorems are very important to find initial value, final value of f of t, as well as to find convoluted signal. Thank you.